Today I'll be talking about the trace element selenium. Sources depend on the soil that the plant is grown in, when we're talking about plant sources, that is. So depending on the area of the country where you live, the same source, such as a mushroom, might have variable selenium content. Meat, seafood, cereals, grains, eggs, milk, and dairy are also good sources of selenium. Digestion and absorption. It's pretty efficiently absorbed through the small intestine. It doesn't look like it's regulated based on current knowledge. C, A, and E, the vitamins, reduce glutathione and enhance absorption. Heavy metals, mercury and phytic acid, the heavy metal mercury inhibits absorption as well as phytic acid. I think if you have mercury in your system, you have bigger things to worry about. Transport and storage, seleno-amino acids probably transport using specific amino acid transporters. It travels free in the blood, and selenoprotein P contains most of the selenium in the plasma. Storage, we see higher concentrations in liver, spleen, kidneys, muscle bones, and erythrocytes or red blood cells, not as high levels in the pancreas, heart, brain, or lungs. Metabolism, selenomethionine can be stored, so that's selenium is stored in that form in the amino acid pool. Selenocysteine is downgraded to free selenide, and then free selenium is converted to selenide as well. Selenate from the diet is reduced to selenite. Gets a little confusing, doesn't it? And then that selenite is further reduced to selenide. Selenide, in turn, is excreted or converted to selenophosphate. So that might take a bit of reviewing. It is fairly complex. Mechanisms of action, functions, disease prevention. For a while, there was a focus on selenium possibly preventing certain cancers like prostate cancer and having a preventative function related to cardiovascular disease. The research has been inconclusive at this point. It does interact with some other nutrients, and on a positive note, it may prevent the toxic effects of arsenic. Excretion, primarily in the urine. Lungs and skin will contribute a little bit, and it's exhaled as dimethylselenide. And when you ingest large amounts of selenium, you get this garlicky odor. Nobody wants that. Recommended dietary allowance is in micrograms, and it does go up a little bit during pregnancy and lactation. In deficiency, there's something called Cachon disease, which results in ultimately in cardiomyopathy, and also Cachon-Beck's disease, which primary symptom is osteoarthropathy. And people also on total parenteral nutrition that I've mentioned in several lectures, so it's IV feedings, tend to become deficient in selenium, so it does need to be monitored and added back to that TPN formulary. Toxicity, selenosis. I don't know if you've ever heard of this, but it was commonly seen in minors and those who consume excess supplements. The tolerable upper intake level is only in micrograms, and it's 400 micrograms. We assess nutriture by blood and plasma concentrations, urinary concentration. Remember, that's how it's primarily excreted. And we do look at some of the selenoproteins, the concentrations, to assess nutriture. And that concludes my lecture on selenium.